for being here, especially given the world situation in this pandemic. So thanks for saving some time to spend this time with us. So yeah, I don't need to introduce myself. Paco already did a great job. Just about the company Recognai, we do a lot of NLP projects for large companies, especially in Europe, for clients like Airbus and large banks in Germany and Spain. And we recently released the BiomeText open source library that I will be using for explaining some of our experiences with say HPO for NLP. So in this talk, you can expect just a brief overview of HPO for natural language processing, and especially a practical example and some practical tips and yeah, mostly my experience and my team experience with these technologies and related technologies such as MLflow or weights and biases. So yeah, we all know that natural language processing is going through what they call the golden age of NLP. So we've seen huge progress in the past years, and we see also that models are getting bigger and bigger. This is kind of a problem for companies that want to exploit these models. Things are getting better with distillation, quantization, and other things that try to make models smaller. But in any case, this is something that should be taken into account when doing NLP, and especially when doing hyperparameter optimization. Also, we see that the transfer learning has arrived to NLP, so it's been used a lot in computer vision before, but now it's kind of the new playbook for doing NLP, like to use a pre-trained model. But this has also implications in the pipelines, so the data processing and the training is getting more and more complex. Just to mention some of the tasks that we work on, the typical automatic classification, data extraction, we do a lot. So yet, please put what I say in context of these tasks. So I will not tell a lot about hyperparameter optimization. I think there will be better speakers to actually introduce the topic during this summit. But basically, what you see on the left is some of the approaches. To be honest, me and my team have been working on the first step for several months before we got into hyperparameter tuning. So the manual tuning, basically what they call babysitting models. So basically trying to manually find the best configurations and do a lot of experiments with trying to understand what works best for the models. So other options are grid search that we are familiarized with, random search, Bayesian optimization, hyperband, and PBT, which is a relatively new method from DeepMind and is integrated in the library I will be talking about, RayTune. So what you see in the figure is the difference between a grid search and a random search. That is from the very famous paper from Joshua Bengio, where they introduced random search. We'll see a bit more detail about these methods during the practical part of the talk. So yeah, what could be tuned in the process of hyperparameter tuning? So mostly anything. So the model architecture, when you are working with classical neural networks, you could think of layer size, type of neurons, dropouts, number of layers, and so on. Also, one thing that is frequently overlooked is the data processing that could be also optimized through HPO. And we will see that this is an important feature also for NLP. And of course, the training parameters like learning rate and schedulers and so on. So I will be using a specific HPO library, which is RayTune, and I invite you to go to the talk today from Richard from Anyscale. I think he will do a great job to explain all the parts, and I will basically show some examples on how to use RayTune for NLP, things like search algorithms, schedulers, and so on. So going into the topic of today, so hyperparameter tuning for NLP has been has not been looked a lot in the past years, but things are moving really fast. So, for example, the transformers library that is basically the new model hub for NLP. They just released last week into the master branch an integration with RayTune, Optune, and so on. And we are seeing other players such as AlllenNLP that they released some months ago as well, AlllenTune library. They provide different algorithms and different approaches. So some of them integrate these libraries inside their APIs, and some others allow you to actually use the libraries for HPO in combination with the NLP library. And basically, this is the direction we took for Biome. For Biome Text, we basically help you to build RayTune experiments, but then you are free to actually use RayTune. So we didn't want to integrate HPO as an API function, for example. So we provide the tooling around it because we believe that Ray is a project that is moving really, really fast, and we want our users to actually benefit from the evolution of RayTune. So this is basically a basic overview, but actually with modern hyperparameter tuning libraries, you can actually work with any library, especially with RayTune is designed for deep learning and for easily integrating with anything you could think of, PyTorch, TensorFlow, and so on. So what could be tuned for NLP? So classical neural nets, such as convolutional or recurrent, here we could optimize layer sizes, types, dropouts, and so on. For pre-trained models, actually is getting a little bit more complicated because actually for the model architecture is already set up, and typically is already a transformer backbone model. But things that you could optimize are the heads. So with the head, I mean the last layers of the model that are trained or fine-tuned for a specific task, such as text classification, question answering, and so on. So you could actually fine-tune that to find a good architecture. Data processing is something you could and should do, like features, data augmentation, the vocabulary that you are using, either training from scratch or fine-tuning, and also, yeah, the typical training parameters and so on. And regarding the training parameters, it's important to take into account that if you are fine-tuning a pre-trained model, you should actually use, you should be careful of learning rates and schedulers and so on. We will see some pointers regarding that later. So basically, just to show you some examples, this is the integration I mentioned that they released last week. So here you can see that using the Hugging Face transformers trainer, you can actually do hyperparameter search, and you can define the search space, in this case for learning rate and batch sizes and so on. Another interesting pointer is a blog post by the Anyscale team that they released, I think, some days ago, and they actually talk about an experiment with transformers that is not using the integration I mentioned, but their own integrations. In fact, I think they have a trainer for the RaySGD project that is using is actually extending this trainer for specifically for transformers. So basically, I recommend you to read about it, but they show how to go from grid search to Bayesian optimization and then PBT, which is the technique that I mentioned before. Another project is AlllenTune. This project has been for a while, so 1 year, 1.5 years, and they are one of the first to use RayTune for NLP. And basically they provide random search, so they provide a limited feature set of RayTunes, And their approach, as is the one for AlllenNLP, is based more on configuration files, so it's not programmatic, let's say, and command line. And there's also some related research work that is highly interesting. I give you there a pointer. So basically, the way you do HPO with AlllenTune is defining config files. So on the left, we see the search space, so dropout, learning rate, and so on. And on the right, we see the configuration. And one of the complex things that we found and we applied to Biome is that actually some of the layers are, as you have a chain of layers, so for example, you do embedding and then encoding and so on, they have interdependent layer sizes. So actually, the way you do this in AlllenTune is basically using JSON-net. So you define variables and functions and so on, but you need to be very careful not to generate a problematic configuration to send to the HPO process. And this is an example of how we did it and how we do it with Biome text that I invite you to check. Is in GitHub, and also you can find the documentation on that link. So basically, as I said, we try to be as agnostic as possible and not to define our own API for running tune experiments. So basically, what we do is provide a series of tooling and API functions for defining your own parameter space, your own experiments, and then use freely the tune APIs. So for example, in this case, we are defining a search space for learning rates and weight decay and so on. And we provide grid search, random search, integration with Hyperparameter and so on. So we try not to be so, to reduce the feature set of Tune actually. So yeah, this is the library. We've been using it internally for many projects, and we hope there's value for other people. Basically, the core of it is AlllenNLP, and also with an integration with Hugging Face. And we try to make things as easier as possible and provide good defaults for actually going from research or experimentation into production. And we've been using this for many large projects already. So this was it for the first part of the talk. In the second part, what I would like to do is to show a practical example. So I think every talk I've seen about the hyperparameter tuning, I think it's the best ones are the ones that provide actual code and actual examples. So I will try to show you how to go from training a baseline to grid search to random search and so on. And for this, we will be using a data set that is not like a typical benchmark of NLP. It's more like a research data set, but it's been used in several tutorials lately. So that's why we picked this one, because you can find tutorials for training, for example, transformers with this data set. And here we will focus exclusively on the classical neural nets. And then we will see that a comparison between the number of parameters and so on, that we believe they are important for going into production. So transformers are great and they are good for many problems, but not for every problem. So sometimes we find clients that they don't want or they can't invest in having GPUs, for example, for the training, or GPUs for inference and so on. So basically I will switch into Jupyter. Can you see it?
Yes, looks good.
Okay, so yeah, this will be, I will not be running a lot of or any code, but actually I will be showing you different steps for doing HPO for this task. So just to make sure that you get the key takeaways from this part, because then I will go into many details and I don't want to forget, and maybe we don't have time at the end. So yeah, some of the key takeaways of applying these techniques that we found during our projects is, the first thing is to look at your data. So sometimes we don't look so much to the data, and we believe more like single number metrics. So I think it's really useful to look at the data from the beginning, to look for quality issues and so on. So this is a general recommendation for NLP, but I think for doing HPO that is actually trying to maximize a metric, I think it's even more important. So always start with a simple baseline. This is something that is also for newcomers to NLP now that you can get access to huge models. This is sometimes overlooked. And for example, for this data set, we've seen many tutorials doing transformers, and they don't provide good metrics even with these huge models. So it's easy to beat some of the models available with transformers with a simple baseline. The third one would be to keep it small at the beginning. So with that, I mean to start doing HPO with a subset of the data, and then always do a smoke testing. So that meaning running just a small set of trials before you actually run the experiments, because one of the things of HPO is actually to reduce cost of training. So this is something that you should keep in mind. Also, we found that doing grid search, as we will see with RayTune, with a small subset, can give you good insights into the problem, the data, and so on. So before starting with more complex methods, we recommend to do a small grid search where you can actually see the importance of certain parameters and so on. And another related thing, and that it's easier than ever with RayTune, is actually to use schedulers. Basically, schedulers, what they do is to stop the worst trials, and you can actually use these schedulers, such as asynchronous hyperband, for grid search. So you don't need to run all the combinations or the product of all the parameters. You can use ASHA for stopping the grid search. So track the number of total parameters, the trainable parameters, and the total parameters of the model. We are talking about neural nets all the time. So this is something that it will be actually useful for the future if you plan to move this into production. And also we recommend to connect all these runs and all these experiments with model registries such as MLflow, as we will see in the example. And yeah, some other things. And finally, yes, related to the first point, please test and analyze beyond single metrics. You can use interpretation methods such as integrated gradients, and you can look at papers such as Checklist from this year's ACL. This is such a great paper that I recommend you to read, to actually go beyond precision, recall, and so on. So the first thing, we will look at the data just for you to get an understanding of what we are doing here. So basically this is the exploration interface from Biome. We are exploring the test set, and we are exploring it with regards to a trained model that is actually on par with transformers, and it's a really basic model, 2 million parameters. And basically what you see here are the examples, the true labels, and the predictions. And then, so we will be dealing with a classification of short text for emotions, so joy, sadness, and so on. And then we can see here the confusion matrix with regard to the model. For example, if we filter here. So this is a way to actually understand a little bit more the data and the problems that you might find. For example, it's not useful to use a lowercase featureization in this data set because it's already featureized. Also, for using transformers, you should use the lowercase models. This is something that if you go directly to train the model and you don't look at the data, you might not see. So the first thing we do actually is to train a really simple baseline. So basically, This is a really stupid model with an embedding layer and then an average of the embeddings. So it's really tiny, but can give you at least a sense of what we will be doing afterwards with the HPO. So basically, if we train this this pipeline, this will be very, very fast. We are training only in 10% of the data. As I said, let's keep it small at the beginning, and then if we use 1B weights and biases, we can check the run here. Up. Yeah. So, by the way, this is available. You can actually, it's a public project, and you can check all the experiments that I will be showing. So, for example, if we go to the baseline, we actually will see that it reaches something like 0.7 accuracy. You can see all the parameters. So biome text will automatically log both the configuration of the model. Even if you are not doing HPO, we will log everything, like the number of parameters, trainable parameters, the tokenization, and so on. And you can see all the metrics here. So basically, running this baseline, we know that 0.7 is like the less we can get for this data. So the second thing we can do is actually just use grid search for the training process. So keep the same silly architecture, but actually try to tune the learning rate and the weight decay and so on with a grid. So as I said, this is really simple. We basically are extending the pipeline with this information, and then we will create the experiment and run this. As I said, we use schedulers. So the idea is that all those runs that are actually performing worse, they will be stopped by this scheduler. So basically, for example, here we launched 12 trials, and 5 of them were stopped. So basically, we did grid search, but with early stopping. So if we go back to weights and biases, we can check. Let me see. So basically, I will remove this, and then I will check the results of the grid search for the model part that I will show later, and the trainer. So basically, we filter this. So we see that with the grid search for the model that we will see in a second, we actually jump a lot in the accuracy. And then, some other things that are interesting in the user interface of weight and biases are the parameter importance. So actually, you can see the importance of some of the parameters to actually guide you in the next steps of the HPO process. We see that the word embeddings, the larger the better. In this case, there's a linear correlation as well with the number of parameters and so on. Weights and biases, they have a lot of useful features, and actually is the most featureful experiment tracking that we tried. We cannot use it every time because some clients you do on premise or you do private, and you cannot use it. So basically, you can expect the same features for MLflow, but probably with a more limited UI. And then I will see the same. I will show you the same experiments with MLflow. So other graphs that are interesting here. So for example, here we see the parallel coordinates graph, where we say, okay, the weight decay values and the learning rates and so on with respect to the best validation accuracy. And this is a really neat way when you have not so much variables to actually check the regions for the best experiments. So going back to our example, so actually with grid trainer, we improved a little the process. So for there we see that the learning rate is an important parameter. Even with a small model, we can improve our metrics by just tuning the learning rate and the weight decay. So the next example could be to actually from the insight that we gain analyzing these graphics in weights and biases, we can set and fix the learning rate and the weight decay to a moderate value, and then we can explore the architecture of the model. So before we were training just with an embedding of 50 dimensions, and then we can do a grid search for exploring larger and larger embedding dimensions. We can introduce character features, and then we can also do grid search on those features. And then encoder, which is actually a sec-to-sec model that is actually trying to contextualize the word vectors and the character vectors. They're the same. We can even check for different types of networks. We could explore here CNNs and other architectures as well. So basically it's the same. And if we run this, we see that we get like a best grid model. Another cool feature that is also in MLflow is that you can rename the runs. So this is a good practice. Actually, if you run like, I don't know, 50 or 100 experiments, actually renaming the runs will help you later to interpret the graphics. So basically, in this case, it was 32 trials, and as you see, 21 were stopped before ending training. So it was pretty efficient as well, even for a grid search. So the next thing, in order to explore a little bit more, and compare the results that we get, remember that we were comparing grid search and random search. Basically, random search will pick some of the values, all the values randomly. So for example, the learning rate, they will be picked randomly for each of these ranges, and it will give you a better exploration of all the possible parameters. So basically it's the same, but in this case with ranges and with this random sets. So in this case, we ran like 80 trials and we got 45 stopped. So if we introduce now the random search, so basically, yeah, we see that we didn't get a better model with random, but we see that we get many other runs that are among the top 10. So basically, yeah, random search. If we continue to do experimentation, probably will beat this metric. So the best grid was cool actually to find, for example, that LSTMs with larger embeddings were the best. But then, yeah, you could switch to random and to Bayesian methods, as we will see later. So the next thing that we try and show here is to actually use a Bayesian optimizer based on Hyperopt, HPO library. And basically, what we do is to say, okay, let's get the best random run. So this one. Let's read it from the logs. So you can read it directly from the analysis from RayTune or from MLflow logs. So you can find the best run in MLflow. So for example, this is best validation accuracy. You can go here, and basically it's the same type of UI, but with less features. So basically this is the same run that we are seeing here in weights and biases. And then you can find here the artifacts that will be important for deploying the model. So basically with this, you can later deploy the model directly into SageMaker, Azure, and so on. So coming back to this, so basically we read the best configuration and we actually focus on exploring a little bit more the training process. So basically, yeah, we will use this HyperOpt library for exploring a little bit more the learning rates, weight decays, and so on. And also another thing you can optimize is the scheduler. So we are working with a really small data set, so it probably overfits in the first few epochs. So yeah, in fact, you can actually even find a good scheduler for this problem with this. So basically, as you see, the way of working is exactly the same. And the good thing is that as you already defined the pipeline before, in the experiment before, or even in the baseline, you can actually just extend it and try to find and fine tune the HPO process. So after running the HyperOpt, we actually get HyperOpt. So yeah, so HyperOpt basically, yeah, as you see, we are actually refining more and more the search process. And in this case, we are using a search algorithm that is taking into account not only the hyperparameters and the metrics for stopping, but also for suggesting the best options. So basically, if we run this, we could get like 0.85, which is in par to, for example, using Roberta or BERT. And I'm not saying that this is a better model, but just for you to get a sense that you can get very good results in a laptop, because I basically was running these experiments in my laptop. And yeah, that's all on my part. We will probably publish the notebook so you can run it and you can check it. And then we have some notes on how to actually take this model into production using MLflow and using fast API and so on. So thanks so much for listening.
Thank you, Daniel, very much. That's very impressive, especially weights and biases. The integration there and being able to introspect and see the visualizations. It's so rich.
Yes, yeah, it's an amazing tool actually. And for example, in MLflow, you cannot log many of the things because things get really slow in the UI, but with weights and biases, it's like really easy to log everything. So basically we log many things like, for example, per class, F scores, validations, and so on. So you can do many things and create reports and graphics, custom graphics.
Fantastic. Okay, there's a few questions coming in. They're coming in from a few different directions, so I'll help relay. First off, from another friend, I want to shout out to my friend and colleague, Chris Fregley. Daniel, you mentioned that certain hyperparameter ranges, such as learning rate, for fine-tuned models may be bound by what kind of a pre-trained model you're working with, such as BERT.
Yes.
Can you expand on that a bit? And Chris adds that their use cases, they're fine-tuning a text classification model on top of BERT, and they're using Keras and TensorFlow underneath.
Okay, yeah, thanks. That's a very good question. And this is an interesting topic because lately what we are seeing is that some researchers and some groups, research groups, are kind of reviewing some of the decisions in training BERT, for example, or Roberta. And there are some papers, I don't have the names right now, but there's one paper that they actually did a lot of experimentation for actually giving a clear recommendation on how to set the learning rates, the weight decays, and so on. And you actually have a table where you can see, okay, for Roberta, those are like the recommended starting points. And basically, yeah, you basically will use some techniques such as a warm-up step where you actually modify the learning rate during the first iterations. But basically, yeah, there are some things to take into account. And another funny thing is that I don't know if you've seen this BERT Adam that was in some of the libraries that they were using BERT. And actually, this was a modification of the Adam optimizer done by the people from BERT. to actually remove one of the terms of the equation to actually train this faster. But actually, after some months or 2 years, people were starting to test this, and actually this BERT Adam was working much worse than others. So basically, pre-trained models can be unstable for training. You should use lower learning rates, and yeah, that would be my recommendation to check these 2 papers that have been published recently for doing fine tuning.
Very good, very helpful.
I think that answers the question, or it was a digression.
Well, another question came up. Supam was asking how to use NLP for identifying a specific phenotype. That may have to do with the kind of use case they have. But you know, in this kind of pipeline setting, how would you, for instance, change it to implement NER, named entity recognition? And also asking about what variants of triggers and word formation patterns need to be put in to get an accurate model.
So the first question is actually how to apply this same thing for other tasks, for other tasks, no, such as name entity recognition.
Yeah.
Is that the first question?
Yes. Basically, you know, shifting over to like an NER kind of use case, for instance.
Yeah, that would be really easy. As I said, our model is based on a backbone model that can be a pre-trained transformer or a custom language model, and then you define like a task head. So basically what you will do this here is to say, okay, token classification, and then my labels will be, I don't know, product, dates, and so on. And basically, in this case, there are some things that you could optimize as well, like the features and also the scheme that you use for tagging. So, yeah. But basically, this will be almost the same. And as I show here, you could even do this with transformers. So you could say, okay, my features for the backbone model will be the transformers and this Roberta. And then, yeah, this is a text classifier, so I will do pooling. But if I want to do a token classifier, I will basically define the type here. And more or less the parameters with regards to training are the same. So basically we have not seen many differences in ranges. And the second question, could you please repeat? Because
you actually covered it there. I think what you're talking about as far as optimizing for the features, that's really what the second part of the question was getting into. Yeah, Savem, if you had a different, if you could post that, but I think that you covered that there. And another question was about, do you have in the slides, or could you post here, the notebook that you went over? There were some questions in chat about if people could run the notebook. I posted something off of the Biome site, but I don't think it's the same example.
No, this is actually, yeah, I forgot to mention this. Let me see. We will be actually publishing this over Twitter because some of the features that I've shown here are not in the current version. So we are 1.0 right now. But basically, what we show in this tutorial that you can find in the website is pretty similar. So the idea is the same. You define the pipeline, and then we actually provide like the raw integration with Raytune. So basically following the recommendations from the Raytune team. So this could be mostly equivalent, but you will need to do more things as the ones that I've shown in the notebook. But we will definitely be posting this notebook with a new tutorial and so on for the new release.
Fantastic. Alrighty. Let me just make one last check. Any other questions? And we can also cover in Twitter and on Slack. Okay. Thank you, Daniel. Thank you very much.
Thanks so much. And thanks everyone for listening. And yeah, I forgot to tell please give us any feedback and anything you might think about the library and or the work we are doing. So this is the way to contact us. Thank you.
Great.